We have here a 5 Newton force acting horizontally to the right, a 3 Newton force acting vertically, and a force of R newtons acting at an angle theta to the horizontal, as shown. We're told that the three forces are in equilibrium, and we want to find R and theta. To be in equilibrium, remember, the resultant of the forces must be zero, and this means that the resultant of the forces in any particular direction will be zero. So we can approach this by resolving this force into a horizontal and a vertical component. The horizontal component will be r cos theta, and the vertical component r sin theta. We can now ignore this force, since its components are on the diagram, and replace it. The horizontal forces must be balanced, which tells me that r cos theta must be equal to 5. The same is true for the vertical components, so r sin theta must be equal to 3. We have simultaneous equations which we need to solve. If we divide equation 2 by equation 1, we get r sin theta over r cos theta is equal to 3 over 5. The r's cancel here, and sin theta divided by cos theta is tan theta. So we have tan theta is equal to 3/5. This gives us that theta is the inverse tan of 3/5, and calculating, this gives us 30.96 and so on degrees, which is 31.0 degrees if we work to 3 significant figures. Use this value when calculating the r. We could use equation 2, and we'll get r is equal to 3 divided by the sine of 30.96 and so on, and this gives us that r is 5.83 newtons, correct to 3 significant figures.